We now address how scientific principles can inform the design of instruction for students of any age. We started by considering how the emotional and physical environment influence cognition and attention. We now move to the next component of the model, designing learning based on the idea that learning is enhanced by providing students with the opportunity for big picture thinking and global understanding of learning goals and objectives. We begin our study of Brain Target 3 with these inspiring words from Maria Montessori. To teach details is to bring confusion. To establish the relationship between things is to bring knowledge. Similarly, Bransford tells us that knowledge is not a list of facts and formulas, but is organized around core concepts or big ideas that shape thinking. And you'll see in this session, graphic organizers are an effective way to help students see the big ideas of learning goals. To demonstrate this idea, take a quick look at the words on this slide. Just view them for a few seconds. Now, test your memory and write down a few words that you remember. Here are the words again. Chances are pretty good that you wrote the word sleep, which, if you look at this slide, is not there. This is a common error. Each of these words suggests the idea of sleep. So why would we think we remembered a word we actually didn't see? Let's take a look at the brain processes involved in global thinking. The principle of patterning describes how the brain brings together disparate ideas into concepts to create new knowledge. We process information both linguistically and visually. However, about 70% of the sensory receptors are in the visual channel. We take in more information visually than through any other of our senses. Pictures are worth 1,000 words. Einstein said he was able to understand ideas only when he had translated them into visual images. So graphic organizers work the way our brain does by searching for patterns and organizing information into chunks. So now let's pull together all these ideas as they relate to designing learning experiences for students. The icon that we use for Brain Target 3 depicts puzzle pieces coming together. Think about trying to put together a jigsaw puzzle without ever having seen the picture on the outside of the box. The individual pieces of the puzzle would have little meaning. Perhaps this metaphor helps us see how we tend to teach students, which often occurs objective by objective, chapter by chapter, one content chunk and then the next. We then expect students to pull it together on their own as to how all of the concepts fit together. In Brain Target 3, we consider what are the big picture ideas, enduring understandings, essential questions, then determining what the students should know and be able to do based on content standards and our curricular goals. In this slide, you see how we start with the content standards and curriculum scope and sequences that will drive instruction. We then design learning units, perhaps a 2 to 3 week content chunk, such as a unit on genetics or a novel study or a science or math topic. And we design then graphic organizers, concept maps that show the relationship among the content, skills, and concepts that the unit will cover. We consider activities that will be used through the unit and how we'll assess learning. This slide shows that the process is cyclical. We're continuously reworking instruction to meet the needs of learners. The benefits of this target focus on the power of the visible. How can the act of drawing and mapping tap on the connection between art and cognition? Concept maps help us to focus on the students' interests, culture, and identities. Here is another idea based on the content of the lesson. Students here explore two versions of an image and determine what might be missing in the history lesson from texts or readings. Students can be invited to develop concept maps related to their personal experiences and expand their interest in the content. In review, this slide shows the steps to designing a concept map for your learning unit. Concept maps usually begin with some informal brainstorming, hopefully with colleagues sharing ideas. Grade level or subject area teams can share ideas in creative ways and then brainstorm on how the content can be visually displayed. In the next two slides, you see how teachers started the concept map with a large poster paper for brainstorming ideas and then developed the map into a more readable program. Here you see some ways to use programs to create final versions of concept maps. There's no one right way to design a concept map. The spider map is commonly used to show main idea, topic, and then details that support the theme. The fishbone is used to show causes that produce an effect. And here is a sequence chart. This slide shows one way to develop a hierarchical chart, beginning with the big idea. I invite you to take your time. Look at all of the examples of concept maps that I've included in this presentation. I hope these examples give you some ideas for your own work in designing concept maps.